Imagine this. You're walking down a quiet forest trail, sunlight filtering through the trees. Everything feels normal, until you stumble upon something that shouldn't exist. A shimmering wall of air, rippling like water. You step closer, touch it, and just like that, you're not in the forest anymore. You're standing in a city that doesn't exist on any map. The sky looks different. The air tastes wrong. And as you look around, a chilling thought hits you. This isn't just another place. This is another time. It sounds like science fiction, but what if I told you that some of the world's greatest physicists have explored ideas that make this scenario, though wildly unlikely, not entirely impossible? To understand how such a thing could even be considered, we need to start with something that's invisible all around us and more powerful than we ever imagined: space-time. Einstein, in the early 20th century, shattered the way we thought the universe worked. Before him, space and time were seen as separate things. You had a clock ticking away seconds, and you had empty space in which planets and stars moved. Simple. But Einstein saw something else entirely. He merged these two concepts into one fabric: space-time, a four-dimensional continuum that stretches, warps, and curves depending on the mass and energy it contains. Here's the strange part. According to Einstein's general theory of relativity, gravity isn't really a force pulling objects together like Newton believed. Instead, massive objects like stars and planets bend the fabric of space-time around them, and that curvature tells other objects how to move. Picture placing a bowling ball on a rubber sheet. It sinks and curves the sheet around it. Now roll a marble across the surface. It spirals in toward the bowling ball, not because it's being pulled, but because it's following the curve. Now take that idea and push it further. What if space-time isn't just curved? It's folded, bent in such a way that two distant points touch each other. This is where things get really strange. Because if that were true, then in theory, there could be shortcuts, cosmic tunnels, gateways, wormholes. The term wormhole was first coined in 1957 by physicist John Wheeler, but the idea had already appeared in Einstein's equations decades earlier. In 1935, Einstein and his colleague Nathan Rosen proposed what they called a bridge in spacetime. Today, we call it an Einstein-Rosen bridge, a connection between two black holes that could, in principle, link distant regions of space, or perhaps even two separate moments in time. Sounds amazing, but there's a catch, or several.
The original Einstein-Rosen bridge is not traversable. You couldn't travel through it. It collapses too fast, like a tunnel that caves in before you can enter. Also, the forces near the entrance would crush anything that dared approach. And even if you managed to enter, the path through the wormhole would be shorter than the time it takes for light to travel the same distance through normal space, but only from an outside observer's point of view. From your perspective, everything still feels normal. That's the weirdness of relativity. But physicists didn't give up. In 1988, Kip Thorne, yes, the same Kip Thorne who later advised on the movie Interstellar, and his colleagues proposed the idea of a traversable wormhole, one that doesn't collapse, when you could actually pass through. To do this, you'd need something exotic, a material with negative energy density. Not just low energy, negative. In other words, you'd need something that bends space-time in the opposite direction of normal matter. Sounds impossible, right? But quantum physics has a way of keeping things weird. Thanks to something called the Casimir effect, we know that negative energy can exist in small quantities. Imagine placing two metal plates incredibly close together in a vacuum. Quantum fluctuations create a measurable force pushing them together. That pressure comes from a region with lower than normal energy, essentially negative energy. It's not enough to build a wormhole yet, but it tells us that the laws of physics don't strictly forbid such things. Here's where the mystery deepens. Some solutions to Einstein's equations allow for closed time-like curves, paths through spacetime that loop back on themselves. If a wormhole's two ends experience time differently, say one end is kept near a massive gravitational object or accelerated close to the speed of light, time would pass more slowly for that end due to time dilation. Connect the two ends, and you could, in theory, step through one side and emerge in the past. That's right, a wormhole could be a time machine. But then the paradoxes begin. The most famous one is the grandfather paradox. If you traveled back and prevented your grandfather from meeting your grandmother, would you still exist to make the trip? Physics doesn't like contradictions. Yet some theories suggest the universe might protect itself. Novikov's self-consistency principle argues that events in the past can't be changed. Your trip to the past becomes part of history. Others suggest multiple timelines, parallel worlds, every action branching into a new reality. It's a dizzying thought. You could step into a wormhole, not just to another galaxy, but to a version of Earth where history unfolded differently.
Still, let's be clear. No one has ever observed a wormhole. No one has created one. These are mathematical possibilities that emerge from Einstein's equations, not confirmed realities. Traversable wormholes require conditions that we can't currently achieve. The negative energy needed might not exist in stable, useful forms. And even if it did, keeping a wormhole open would require engineering so advanced it's beyond anything we can build. Yet something strange keeps happening. Every time physicists try to prove wormholes can't exist, the math pushes back. The universe seems to say, no, I won't make it easy, but I won't make it impossible either. And then there's the silence, the eerie silence of the cosmos. According to the Drake equation, we should be seeing signs of advanced civilizations everywhere, but we don't. What if they found wormholes and left? What if the galaxy is dotted with ancient gateways, invisible to us, waiting for someone to find the right frequency, the right energy, the right moment? Or what if someone already has? There are scattered reports, always unverified, of strange anomalies. Pilots who lose hours in the blink of an eye. Scientists who record data they can't explain. Particles in labs that disappear and reappear a fraction of a second earlier than they should. Most are dismissed, probably noise, instrument error. But what if they're not? What if the universe is littered with hidden passages, flickering in and out of reality, too unstable to see, unless you're lucky, or unlucky? It's worth remembering that the universe is under no obligation to make sense to us. 100 years ago, time dilation and black holes sounded absurd. Today, they're accepted facts. Wormholes may sit on the same edge, waiting to tip from theory to discovery. So the next time you look up at the stars, ask yourself, what if distance is an illusion? What if time is more fluid than we think? And what if, somewhere out there, or maybe even right here, there's a doorway waiting to be opened? Not a portal in a forest, not a glowing circle like in the movies, but a silent, invisible curve in the very fabric of existence. The kind of thing you wouldn't even notice until it notices you. The universe hides its deepest secrets well, but every so often it leaves breadcrumbs, equations that don't quite close, observations that don't quite match, mysteries that refuse to die. And wormholes may be one of them.